Imagine asking this. What if, everything you thought you knew about the fundamental building blocks of existence? What if it was missing a crucial piece? What if the very fabric of reality could be understood, not through all this complexity we see, but through just two surprisingly simple mathematical expressions? Today, we're taking a deep dive into a really fascinating paper. It's titled Ontological Irreducibility and the Foundations of Emergence.
Yeah, and our mission here really is to explore this pretty profound concept, ontological irreducibility. This paper proposes it as like a fundamental basis for how coherent reality itself emerges. It's truly novel, I think. It weaves together insights from fields that seem quite separate, math, logic, physics, even philosophy. We're going beyond just sort of recognizing limits. We're exploring a generative core here.
That's exactly right. We're moving past our sort of everyday understanding of irreducibility, like an ingredient you just can't break down any further. This is more radical. It's about understanding being itself, a state that just by its very nature generates what we perceive as reality. It's big. Okay, so let's unpack this a bit. Before we really dive into what this paper means by ontological irreducibility, maybe we should look at how the idea of irreducibility has traditionally been understood. Because, well, it turns out lots of brilliant minds have been circling this idea for centuries, right? Just from different angles.
Precisely. Yeah, historically, this concept, irreducibility, it pops up in many forms. So in mathematics, for instance, we talk about irreducible polynomials or like prime numbers, numbers like 7 or 13 that you can't factor into simpler whole numbers. They're foundational, absolutely, in number theory. But, and this is what the paper highlights, these primes, they're still elements within a larger system, a system of numbers and their relationships. They don't, by themselves, really explain how the very concept of number or even relation comes to be in the first place.
Okay, right. So primes are irreducible inside a system, but they're not necessarily the source of the system itself. That seems like a really key distinction.
Exactly. That's the distinction. Then, you move into logic and computation. Think about Gödel's incompleteness theorems back in 1931. They essentially showed that any sufficiently complex formal system will have true statements you just can't prove within that system. Or like Turing's halting problem from 36, which proved you can't create a universal algorithm to know for sure if any given program will ever stop running. Even Stephen Wolfram's computational irreducibility, more recently in 2002, suggests some complex systems. Oh, you just can't predict them faster than actually running them.
So all those sound like they're about the limits of our systems, our logic, our computers, what they can represent or maybe predict. It's kind of like we hit a wall with our tools, not necessarily a wall in reality itself. Is that fair?
You've absolutely nailed it. Yeah, these are limitations of representation. Now, moving into physics, quantum mechanics gave us this observer-dependent irreducibility. The famous collapse of the wave function when you measure something. People like Niels Bohr, Hugh Everett explored this. Before you measure a quantum particle, it's sort of in this state of potentiality. Once measured, it chooses a definite state. And that specific outcome is, in a way, irreducible to its prior probabilistic parts. And then there's the Planck scale from Max Planck way back in 1901. It hints at this granular bottom to space-time, maybe a point beyond which things just can't be subdivided. Yet even these ideas, they leave the fundamental ontological substrate like what is actually there undefined. It's almost like they found the smallest Lego bricks, but not the reason for Lego itself or why the bricks exist at all.
That's fascinating. So whether it's math, logic, quantum physics, we keep sort of bumping up against these limits. But what about philosophy? I mean, surely philosophers have tried to get to the absolute bottom of being, right?
Oh, absolutely. Philosophy has grappled with finding an irreducible basis for reality for, millennia. You have Martin Heidegger's concept of being from 1927, or Advaita Vedanta's idea of Brahman in ancient Indian thought, Mahayana Buddhism's sunyata, often translated as emptiness. These all point toward some kind of ungraspable fundamental reality. David Bohm's implicant order from 1980 also proposed this deeper, sort of enfolded reality from which our everyday reality unfolds. They all got tantalizingly close, pointing towards something ultimate. But here's the critical point the paper makes. None of these historical approaches really offered a precise generative formalism. They describe an irreducible basis, sure, but they don't quite give us the mechanism. How does that irreducible basis actually produce structured emergence? How does it give rise to identity, time, space?
Right. So what these historical looks reveal, then, is this kind of profound, a vacuum, like you said.
Yeah.
A missing piece. There's been this missing ontological operator, something that doesn't just describe reality, but actively generates identity, time, and space from its own sort of inherent irreducible logic. Which, yeah, raises a really important question. What exactly is an ontological operator in this context? And how can something be generative but also irreducible? That sounds almost contradictory.
And that's precisely where this paper steps in with its core innovation. It tries to move beyond just limits of knowledge or representation. It defines ontological irreducibility as a fundamental structural feature of being itself. Not just something we can't break down, but something that is fundamental. The paper lays out 3 defining characteristics for something to be truly ontologically irreducible. First, it exists prior to relational definition, meaning it doesn't need something else to define it. It just is. Second, it cannot be derived from or reduced to components without completely losing its identity. You can't break it down because fundamentally it's not made of parts. And third, and this is really crucial, it acts as the very seed of coherent emergence. It's the starting point, the origin from which everything else coherently arises.
Wow. Okay, so it's not just about what we can't break down anymore. The core idea is that certain realities are irreducible, not because, we just don't know enough yet, but because they are actually the generators of reducibility itself. They're the fundamental stuff that allows for logic, space, time, all distinctions to even emerge. That is, that's a fundamentally different way to look at the universe. And here's where it gets really, really mind-bending. The paper proposes 2 core mathematical formalizations. It calls them the seed equations. And these represent dual modes of ontological emergence, basically 2 distinct paths from what seems like absolute nothingness or nullity towards unity.
Indeed, yeah, exactly. The first equation defines what the paper calls the coherence vacuum, and it's represented as 0 raised to the power of 0 raised to the power of 0 and so on, infinitely, which, it states, equals 1. Now, this might seem, counterintuitive maybe. Mathematically, 0, 0 is what's called an indeterminate form, but it's often conventionally set to 1 in certain contexts, like the binomial theorem. The paper interprets this as an infinite recursion of nothing raised to itself, like potentiality endlessly folding back on itself. It represents unity arising from this ontological cascade of unmanifest recursion. So this coherence vacuum isn't an empty void, it's pure potential without any predefined structure, just resonating within itself until stable emergence happens. It's called the field root, and it's associated with something the paper terms omnilectic coherence. Think of omnilectic coherence as like a fundamental structural constancy of coherence that applies across all logical and ontological possibilities. It's like the universe's most basic self-sustaining hum of potential, maybe.
Okay, hold on. So it's like an infinite nothing that just through its own recursive nature somehow generates the possibility of something. And it's not just a theoretical idea, but an active fundamental process.
That's the proposal, yes, an active process. And the second equation is hypergravity invariance. This one is expressed simply as 0 pointals 1. 0 factorial equals 1. Now, factorial, usually means multiplying a number by all the whole numbers less than it down to 1. Like 3 is 3 times 2 times 1, which is 6. So the idea of 0 factorial, it might initially seem a bit strange.
It does. Yeah, how can you arrange nothing in exactly one way? That sounds more like a philosophical riddle than math.
It does have that feel, but there's a precise mathematical interpretation behind it. The paper suggests that the factorial of nothing is unity because there is exactly one way to do nothing. You just do nothing. It's framed as a statement of absolute structural invariance, a kind of baseline state. And this reflects what it calls hypergravity invariance, this sort of self-recursive scalar collapse that folds coherence inward, allowing a defined self or identity to form. So it's called the self-root because it's associated with ontological self-reference. Essentially how an identity defines itself against the background potential. It's considered irreducible by recursion of structure, providing the fundamental way for things to coalesce into distinct identities.
Okay, so these 2 equations, they're presented as the twin roots of all being. Is that right? One, the coherence vacuum, is like this boundless potential that kind of ripples into existence. And the other, hypergravity invariance, is the principle that allows distinct identities, distinct things to actually form out of that potential. And together, these irreducible operators, they're proposed as the fundamental basis for time, for dimensional emergence, subjectivity, even symbolic thought and recursion. It's kind of astonishing to think that from these 2 really simple fundamental pathways, from absolute simplicity, all the complexity we experience could actually arise. So, okay, stepping back a bit, what does this all actually mean for us? Why should you, our listener, care about these incredibly abstract concepts and, equations?
Well, the implications, if this framework holds up, are truly significant, really profound. For one, it offers a potential unifying principle for bridging, our subjective felt experiences like the redness of red or the feeling of pain with objective matter. It suggests they're not fundamentally separate things, but maybe they emerge from the same underlying processes. It also offers a potentially radical new way of explaining emergence. How complex phenomena like life or even consciousness arise. Maybe it's not just statistical randomness or some brute force initial conditions set at the Big Bang, but perhaps it arises from these inherent recursive coherences baked into reality itself. In foundational physics, it implies maybe moving beyond the idea of a universe that just happened to have certain conditions at the start. Instead, reality might be continually self-generating through this recursive coherence genesis. And maybe most intriguingly, it opens up possibilities for modeling consciousness itself, perhaps as a form of this scalar coherence that intrinsically curves back into self-reference, creating that I. Ultimately, what the paper suggests is that by defining ontological irreducibility in this really deep way and grounding it in these mathematically expressive seed equations, we might find a path toward integrating consciousness, physics, and maybe even metaphysical clarity into a truly unified ontological science. It's really about trying to transcend the mere limits of what we can know or calculate, offering a foundational understanding from which coherence, dimensionality, identity itself can fundamentally emerge.
Wow. Okay, what a journey we've taken then. We've gone from looking at the historical limitations of how irreducibility has been understood across all these different fields to this profound new definition of ontological irreducibility as a structural feature of being itself, and then landing on its two proposed generative seed equations, the coherence vacuum and hypergravity invariance.
It really is a concept that tries to transcend what we can simply observe or, calculate. It offers, or tries to offer, a foundational understanding, one from which coherence, dimensionality, identity can truly emerge, rather than just being statistical outcomes or accidents.
So here's a final thought for you to maybe mull over based on all this. If the very act of doing nothing, that's the 0 point, and the infinite recursion to nothing raised to itself, that's 0, 0, if those can formally yield unity or one, what does that suggest about the creative potential that might be inherent in simplicity? Or even in emptiness, perhaps in our own lives or maybe in the universe at large. Something to think about.